join. What about others? If the link is not visible to everyone, please share in the group.
Ma'am, the meeting just got ended. Please give us 2 minutes and we're joining back.
Okay. Once you check the Moodle, the participant list, actually now it's visible to me. Before it was I and J section. Now they changed to K and F section. So I think it may be visible to your Moodle. Once you check the class is visible or not. Actually, I got one mail from Moodle team regarding this. Yesterday, I mailed to Moodle team regarding this issue. Then they cleared those. They said it's already cleared, updated the list, but still it's not available to you, right?
Ma'am, in Moodle, it is showing one of our open elective, ma'am.
Which one? SCM?
We have, for me, like it is showing software requirements management. Whoever has it.
Software requirement management.
Ma'am, in Moodle.
Moodle 10 to 11, it says software requirements management.
Software requirement management. Is there any subject like that?
Yes, ma'am, that
elective,
is one of our
actually.
elective.
Maybe it's a new elective. It was not there before. Software requirement management. Okay, it's, which one is correct? Is it an elective time now?
No, ma'am.
No, ma'am.
As per my timetable, it is SC only.
Yes, ma'am, your timetable, I mean, we have the same right now.
Before actually this your student list were not added to my Moodle. So even though I created the Zoom link, it was shared with some other groups like I and J sections. So those people were joined before. So yesterday I contacted the Moodle team and they said it's updated with new list.
Yes, ma'am.
Still problem is existing, then I have to contact them again.
It's okay, ma'am. You can directly share the link to us.
But it's difficult, right? Every day it's difficult to share the link through the WhatsApp.
Yes, ma'am. Yes, ma'am.
The other one we can directly join.
Yes, ma'am.
So I have to rectify this problem, not only for your section, the other section also facing the same problem, even including lab. Suppose if I forget to share the link before, it would be difficult at the time. So, and I'm not sure about the attendance also. So what is the problem right now? The link which I created is not available to you, right?
Yes, ma'am.
Okay, after the class, I will check once more. I'll create the laboratory links. Then we'll check whether it is visible to you or not. Okay. But now it's showing your section in my Moodle. I don't know why it's not visible to you. Have you seen the syllabus? New syllabus? Yes, syllabus. What about the Coursera courses? Did you get the link?
No, ma'am.
Actually, I will share you 2 links. Software design and architecture specialization and software development lifecycle specialization. Hope everybody is having a Coursera account, right?
Yes, ma'am. Yes, ma'am.
So you have to do this Coursera courses and try to finish as early as possible. 2 courses link I will share with you. Okay. So you have one class group there.
Yes, ma'am. We have the
Okay,
normal
then I will
classrooms.
share this to Abhishek.
Okay, ma'am.
It's already shared with Abhishek. Abhishek, please share in the class group.
Okay, ma'am.
First, you should do the second course, software development lifecycle specialization. Okay. Software development lifecycle specialization. Second, once you complete that one, you can go for the design and architecture specialization. So try to finish within 2 months. Okay. And after, once you complete this course, you should submit your certificate PDF form. So try to finish within 2 months. It's very easy. Once you start early, you can finish early. Very easy courses. And some peer assignments also there in that. So the thing is that you should not copy the assignments. If you copy the assignments, definitely you may face some problem with plagiarism. So you should not copy assignments. The remaining things are very easy. Even assignment also easy, but
both the courses.
Sorry?
Should we complete both the courses or any one?
It's better to complete 2 courses. Anyway, the first one is mandatory.
First one is life cycle and specialization. Yes, ma'am.
Okay, yes, software development, life cycle specialization, that is mandatory. It's displaying, it discuss about all the phases of software development. The second one contains architecture and design. That is one of the phases, but more in detail. In that one, I think Agile, Lean, some sub courses are there, right?
Yes, ma'am.
And that one is not mandatory. That one is not mandatory. The University of Minnesota one course is there that first you start with that. That is the basic thing.
Okay, ma'am.
Once you complete that, you can go for the second one, software development lifecycle specialization. The lifecycle contains all the phases. So once you complete the course, you may get an idea about software engineering. Okay. So before have you seen your syllabus? I will share this syllabus with you. If you did not see the syllabus, I will share the syllabus. Abhishek, please share the syllabus.
Links for the specialization,
Yes, ma'am.
not the courses.
Sorry?
We have got the links for specialization, not the courses, ma'am. I mean, like, there are a bunch of courses we need to complete.
In that one, first one you do.
Okay, ma'am. Thank you.
What is it for first course name? It contains some 4 courses, I think.
Software development process and methodologies.
That one, first you have to do that one. The next is
Agile software development.
Agile software also is there. This, as per this new syllabus, Agile software is there. Agility and process is there. Then what is the third course?
Lean software development.
Lean software development is not needed. Lean software is not coming in this subject. Okay. Next is
Engineering practices for building quality software.
that also actually it's good, but it's not mandatory. Then in the second section, what is the what are the courses? Says software design and architecture specialization. That one.
Object-oriented design.
Object-oriented design. Okay.
Design patterns.
In object-oriented design is close to this. Design pattern is not needed. Object-oriented design actually design part. UML, unified modeling language, the diagrams you need to, class diagram, object diagrams are there in the assignment part. Okay, that one is good for you. Object-oriented design. Okay, next is
Design
pattern is not needed. Next,
software architecture.
Software architecture. Okay, we are covering software architecture, but it's difficult to do all the courses, right? So you can leave it there. Next is
service-oriented architecture.
Service-oriented architecture as an elective for the next semester, so you can leave that. Okay, I already shared the syllabus. Once you go through the syllabus, I'll share the screen. Actually, this is our syllabus, software engineering. First, the course aim is to help the students to build up an understanding of how to develop a software system from scratch by guiding them through the development process and giving fundamental principle of system development with object-oriented technology using UML. Means, what is our intention? Why we are going for this course? Because you, anyway, in future you will be in software sector. Then you need to write software coding part, means coding. But the entire project, how to develop a software, how to develop a software system from the scratch, using the some techniques, some ideas you will get from this course. So you can apply those development process, like where you have to apply the traditional methodology, where you have to go for the lean, where you have to go for the agile methodology. That kind of idea you may get from this once you complete this course. Then you can use some object-oriented technologies like unified modeling languages. It's a tool for designing. So you will learn at least one tool. I don't know about syllabus. Maybe it's Star UML or Visual Paradigm or Rational Rose. Any one of the object-oriented technology you will learn. That will help for the development. You can do the same thing without a tool also. You can, but the tool give more perfection, more quality for your design. So that we will learn in the laboratory periods. Okay. The course will initiate students to the different software process models. We will discuss the different software process models, software requirement engineering process, system analysis and design as problem-solving activity, key elements of analysis and design with system development lifecycle, giving the student insight into learning the quality method, testing methodology. Means In the software development process study discussed, right? What are the different stages? What are the different stages for development, software development? We will discuss each and every phases. Anybody remember what are the different? I'm not sure whether I discuss with you with your section or the other section. Okay, actually we will discuss. I'm not sure. I don't remember whether I discussed yesterday or not. This. Okay, these are the different phases of development. What is the first phase? Here you can see updation, updated requirements, system analysis, design, code, deployment. These are the software. Product spelling is wrong. Actually, this one I. Anyone? Okay, you are going to develop a new software. From where? Actually, we are going to develop a new software from the scratch. So from where you're going to start? These are the phases.
Development.
You can see the hexagonal boxes outside. These are the different phases, but which one is a starting phase? Can you find out which one is a starting phase? Is it visible to everyone?
Yes, ma'am.
Requirement.
Which one is a starting phase?
Analysis.
Code design.
Code designing. Okay, tell me. Okay, you can think about it because we did not cover the portion. So just think about which one. So if suppose you're going to develop a new software from the scratch because you don't have a software to modify. Reusable software is not with you. Then you should develop something from the scratch. Nothing is there. You don't have any idea about the software project you are going to do. Then from which phase you will start? Yesterday class, I discussed every software is a customized product, not like the other hardware things. Because you are developing a software for a particular organization or a customer. Maybe you have a customer. So you should start from the customer requirement. So the first phase is? Requirements. You should collect the requirements from the customer. So how can you collect the requirements from the customer? Actually, requirement engineering is a branch in software engineering. Requirement engineering means how to collect the requirements. The requirement collection is very tough, very long process because you should collect the exact requirement what he needs. Sometimes you may interpret in another way. Sometimes you did not clear about what he wants. Sometimes the customer itself is not clear what he needs. Sometimes geographical distance is there. The customer is somewhere else and he's contacting through phone. You can't go there and talk with him in person. So definitely there is a gap between the customer. So there is a gap between the customer and the developer. So the requirement collection is the first part. It is very, very difficult part. Some of the reasons I discussed now. Why this requirement collection is difficult. Okay, when you hear about requirement collection, you will think it's very easy task to collect the requirements. When you approach the, suppose if it's a big budget project, you should first, there may be a team, requirement engineers team are there. They will discuss with the client what he actually needs. So the client sometimes is not clear. Sometimes he is not clear about what he needs, but he know the output. Okay, some vague idea, he has not a clear idea. So there is a gap. So there are multiple ways, not only through the, you can go for survey, you can go for brain-based discussions, you can go for questionnaires. There are many methods to collect the requirement from the user. It depends on the project. Depends on the project. It will vary. The next is system analysis. What is system analysis? Next part is system analysis. What do you mean by system analysis? Think about it. Analyzing something. What do you mean by analyzing?
Can the system run it?
Yeah, you need to calculate the requirements, whether it is possible or not, because the customer is not thinking about the technical side, how to implement. He is not bothered about it. He is just discussing what he needs. But as a developer, you're always worrying about how I can implement it. Is it possible to implement? Is it technically feasible? Is it economically feasible? That is your question. You are always worrying about that part, but the customer is not worrying about the implementation part. He is actually expressing his requirements only. So analyzing those requirements, whether it is technically and economically feasible to implement, that is your part. You should do that. That is system analysis. Suppose if some of the requirements are not possible to implement, you can negotiate with the customer, because sometimes you can say that, okay, this is not possible within the particular budget. So you can go for you can ask for more budget. And suppose if it's not possible to implement, you can tell it this is not technically feasible because the current technology does not support this implementation. So you have the option to negotiate with the customer. So analysis part is feasibility checking comes under this, and whether the technical side, economical side, everything is checking this part. Next is designing part. What is designing? What is designing?
The UI.
Sorry?
The interface and all.
Yeah, UML is also, UML means modeling languages you can go use for the designing. Of course, you can use modeling languages for designing. That is a tool to design. Okay, without the tool, you can use the same thing. You are drawing the class diagram, object diagram, sequential diagram, or different types of nine behavioral diagrams are there, structural diagrams are there, different types are there. So some 9 to 12 diagrams are there. So these diagrams actually we are designing from lower level to high level. Means lower level to high level means there are, when you discuss things in detail, you should learn about the objects, you should learn about you should design the classes. Once you, for example, in an object-oriented program, you are going to write an object-oriented program. You should fix the class, you should fix the objects before you're going to write the program itself. That part comes under designing. It's like a building construction. Before you're going to construct a building actually, you are going for the design phase. What is the design phase? You will draw the plan, elevation. Plan means building top view, right? Once you remove the roof, when you look from top, how it looks, how the rooms are arranged, you will get an idea. That is the plan of building. And what is the elevation? Elevation means how the building looks like from the front view. Okay, then cross-sectional views. You can draw different kinds of views. That is a designing part, right? And architectural design means we are designing the interior parts. So designing phase is not you always do before the actual implementation. Actual implementation means you are constructing the house using the materials. So here, coming to the software, what is the designing? What is the what is the actual development is? Here actually system design and code design is showing separate phases, but it's not separate phases, it's single phase only. System design means hardware designing, and code design means the actual code, means classes, objects that you designing. That is code designing. So these two, code design and system design, you can to integrate in single phase. The next is, what is the next is? Actually, this is not code design. I will change this diagram because it's not a design part, actually implementation part. Code implementation is. What is implementation? When it comes to the software, what is the implementation phase? How can you implement software? Already said, when it comes to constructing a building,
Creating
construction
creating
using,
each blocks for the this thing.
you're actually writing the code. You start writing your program. The programming part is the actual implementation part. Coming to the software, you can't directly write one code without the designing and feasibility study. It's not a single program like yesterday what I discussed with difference between a software and a program. Program contain a set of instructions like a small, generally it is very small. If you find any mistakes, it's normally support a single function. So if there is any mistakes, you can easily find out. But software is not like that. Software, it's very complex one, right? It contains so many supporting libraries. So that we develop for multiple functions, and it has lifespan. And it's during the lifespan there is a need to change sometimes as per the user requirement. There is a need for changes. So you can able to do that change also. That is that updation part, that is updated. I will change the diagram. Okay. Actually, updation is the next. Deployment. What is the deployment is? Deployment means once you develop the software, you hand over the product to the customer. That is the deployment phase. After the deployment, okay, generally for a hardware product, you may specify it's 1 year period, warranty period is there. Within 1 year warranty period, if there is any, once it's handed over to the customer after deployment also, if it has, if the product has some issues, technical issues, and not due to your mishandling, the other way, if there is any technical issue for a period of 1 year, they may correct it, right? In the same way, a software also having a warranty period, like means it years may vary based on the software complexity. So that period, if the requirement is changing, you should be ready for the updation. That is the next phase, maintenance part, updated. So the first phase is requirement collection or requirement gathering. And next is system analysis. We'll check whether the particular software requirements, what you collected are practically, can you able to implement it or not. The next is based on the finalized requirement. You have a SRS document is there. SRS means system requirement specification document. After the designing, after the first analysis, you have a system requirement specification document is there with you. It contains all the feasible and non-feasible requirements. You have to list all the feasible and non-feasible requirements, and those requirements, based on that, you can go for the designing phase. Okay, you can design. None of these phases are permanent, because it will change. It may vary based on a requirement, change in the requirements. The next is code implementation. Then deployment means hand over the product after the testing only. After testing phase is there, but it's not mentioned here. It's part of implementation. In many diagrams, it may not mention that stage, but there's a stage called testing. Once the testing is okay, they will hand over the product to the customer, and that is the deployment phase. Once you give a quality product to the customer, still it may need change in the requirements. So you need one more phase, that is updation or maintenance phase. Is it clear?
Yes, ma'am.
Okay, these are the different phases of software product. Software product as yesterday we discussed about the lifespan of software and hardware products. What is the failure rate? We discussed, right? But can you tell some other differences between software and hardware? What is the difference? Yesterday we discussed some characteristics.
Software involves coding, ma'am.
Yeah, of course.
Whereas hardware involves electronics.
In hardware, you are assembling some hardware things only.
Yes, ma'am.
So each and every part has some there is a chance to wear about, right? It's because it's a hardware thing. It may deteriorate after a period of time. Okay, lifespan is there for every hardware thing, not like software. So hardware assembly, right? So the characteristics. Software is developed or engineered, not manufactured. The first thing is, you should not use the term manufacture as software. Manufacturing is not related to the software development. Software is always developing or engineering, not manufacturing. Manufacture word that you can use with the hardware things. The next is software does not wear out but deteriorate. So wear out period is compulsory for every hardware thing. Exactly. Every hardware, every electronic or every hardware things, it has a wear out period. The next is no spare parts for the software. It's very important. You know, we cannot, suppose if one software is not working properly, you cannot change one particular spare part, like hardware things. Hardware things you can check where it is, which part is not working perfectly. Then you can replace it with another spare part. That option is there for hardware things, but software, there's no spare part. Software indicates error in design or development. But for hardware things, once you complete the manufacturing, then only you could identify whether it's working properly or not. But coming to software, you may get chance to find out the error in the previous stages itself. Even during the designing phase or development phase, you can find out errors. How can you find out errors? In design and development phase?
While compiling.
Yeah, of course. That also, while compiling development, suppose coming to software, there are so many modules, not only one module. So even each and every module we are checking separately. There is, before you coming to the system testing means once you complete the whole system contains many modules. Before you come to the system testing, you have module testing is there. Module, each and every module, once you develop, you have to test. How can you test it? You have a test case, right? Each and every test case contains an expected result. You're checking with the expected result. So if it's not matched with the expected is what you get, you can easily mention, okay, you can easily understand. I made it mistake. So you can modify in the particular module. So different modules may be developed by different teams. So at last, you integrate all these modules. Once you integrate all these modules, again, you may experience some problems. Even the standalone unit, each and every module is a standalone unit. Okay. The standalone unit may work independently, but once it integrates, we are not sure about its working. So you will go for the integration testing. And once it's integrated, the entire modules you integrate. One module 1 is integrating with module 2. Then you are going for integration testing. Again, the module 1 and 2 integrate with module 3. Again, you have to do the integration testing. The testing will repeat till you create a system. Once you create the entire system, you can go for the system testing. So that is the last one. So there are multiple tests are going in the software development phases. It's not a single phase process. It's just testing. Generally, when we are drawing, we used to draw the testing phase after the development. But in actual case, the testing is not happening in the last phase. It's a continuous process from the initial phase onwards. Every time we are going for the testing, even after the requirement collection also, we are creating a specification list. The specification list actually, it will check with the user requirements again, whether you completely cover all the requirements or you missed any of the requirements. You used to check with the list. We have a checklist. So from initial onwards, there are multiple ways to do the testing. There are automated test tools are there. That is like a designing tool. Tools always not a mandatory thing, but for a sophisticated software, it's needed to reduce a human effort and for the quality. So that is the next difference. No spare part for software. Software indicates error in design development. Every phase you can find out. You have a chance to find out the errors. But coming to hardware thing, once you assemble everything, once you create a system, then only the system term you can use for both hardware and software. What do you mean by system? The term system you can use with both hardware and software. Generally, you call system means your computer system. But is computer is only system? You heard about many systems, right? Ecosystem.
Yes, ma'am.
Yes. Coming to human body, there are so many systems. Skeletal system, excretory systems, digestive systems. Every time you are using this term system, what is the system? What is the common for all the systems?
When everything works the way it should. Like it's intended.
System means all system have one common property. What is that? Whether it is computer, whether it is biological systems or ecosystems, all systems have one property. What is that property?
They do their designated task.
Sorry.
They do like the task designated to them.
Yeah, of course, they are processing something. All system have one processing. You have to feed one input, you will get an output. So all the system, whatever a system means, it's a closed system or open system. A system always having an input, an output, a processing unit. So generally, we mention the system, computer system, because this computer also having an input, an output, and processing unit. The other systems which I mentioned, all systems have the same property. So sometimes here itself, I said software system, software systems. Software system also having the same thing. You are feeding input, you will get output. Something is processing in between. The processing part you are calling the software your software. Okay. Then is it clear? Because you don't get confused with the term subsystem when I'm using. The software are mostly custom built. Custom built means I already mentioned. Customized, because not like hardware, the fan, lights, even the computer. What are the other hardware things? Even the mobile, it's not customized for a particular person. But coming to software, it's customized for a particular organization or a customer. Even the billing system, you can tell the billing system as a software, but that billing system is vary from organization to organization. Depends on their requirements, depends on their input, depends on the product which they are using. It will vary. So we can call it as a customized thing. Okay. Is it clear the topics which we discussed today?
Yes, ma'am.
I'm not getting enough response.
Yes,
Only
ma'am.
2 members responding.
Yes, ma'am.
It's 10:48. 2 more minutes. Is there any doubts?
No, ma'am.
No doubts. I used to finish my topic within the period because you need a gap between 2 classes. I think you need some time to refresh. So always I will try to finish within the period. So the last 2 minutes, any doubts?
No, ma'am.
No doubts. What's your name?
Vidya, ma'am.
Vidya.
Yes, ma'am.
Okay. Only Vidya is responding. Vidya is the only one female responding. One student, one girl student. None of the girl students are responding. And what about boys? I heard 2 boys sounds also in between. Who are they?
Yes, ma'am.
Yes. Tell me your name.
Sharat, ma'am.
Sorry.
Sharat, ma'am.
It's not clear.
Sharat, ma'am.
Sharath. Sharath is responding. I heard one more sound. Sharath and Abhisheka. At least I have to know some students' name.
Yes, ma'am, it was
Yes,
me.
ma'am.
Sorry? Okay, always. Anyway, the online sessions, you should respond. Otherwise, we are teaching the computer, right? It's not like classroom. Some batch students always respond. Some. But anyway, what questions I'm asking, it's just think about things. It means I'm not expecting the exact answer, not expecting the correct answer. I just expecting your response, how you are thinking, what you understood. That's it. I'm not expecting the exact correct answers. What is there? But you should think badly. You should think something. Okay then. Thank you all. We'll see you in the next class.
Thank you, ma'am.